Hello, can you everybody hear me?
Yes, we can hear you and we can see your screen as well.
Excellent, very good. Okay, thank you again for inviting me to say a few words at this workshop, Chi at the Edge. And thanks to Kate for organizing this workshop and of course our great work with the Chameleon Testbed. And I think Kate made a very important comment during our session that the important part of the session actually starts at 1 o'clock when you hear all the other talks. So I am just a sideshow for this program. But what I wanted to do is that I cover a little bit to give you a broader perspective of research infrastructures that we support at NSF. So that gives you other things available as well as how you might be able to connect in the future different infrastructures to do bigger and larger projects. So a broad way to look at the infrastructure project is that in the directorate we support is two directions to look at it. One is from the x-axis, we put it what is called the individual / institutional versus community, and the y-axis is in terms of the size of the project. So I won't go over all of the acronyms, but I want to give you some flavor of that. CISE STAR stands for Campus Cyber Infrastructure Program. It's about in the order of $1 million or so, multiple tracks. Actually, the CISE STAR has a upcoming deadline coming up in October 11 for those who are interested in it. In terms of, besides providing infrastructure connectivity for campuses, so to improve the possibility to do better science in terms, with higher bandwidth and everything, I handle a track called Area 3, which is actually related to network innovation and applied research idea. So there you can connect things in terms of something you have done research already, you want to bring it there, that will help to improve in terms of where that is. And so of course for that you need to have a science driver. So that's where this one you see is. MRI stands for the major research instrumentation that actually can, depending on what it is, it can fall more in individual or institutional level to the community level. It's in the range of about $4 million. CSSI is kind of an interesting one. I had to do it like this slanted oval shaped thing because of the size as well as the scope of what it is. It stands for, it's related to software infrastructures that you might build it, and you want to look out for that program because it brings a lot of value to the overall community. Again, this one falls into either of those groups, individual or institutional, or the community, depending on the size. Then on the right side, if you can see my cursor, is that I have the CCRI, that stands for CISE, Community Research Infrastructure. That's a very important program we have. They're in the range of $2 million for a new proposal or enhancement proposal, or you can do a grant proposal in the order of $5 million. So, this one is, as the name says, the second C there is for community. It's in the range of, in that range. And that one usually, we had usually last year, the deadline was in January or so, you might want to look for that one. And that one is open in terms of within the computer science community, anything you want to actually do. I want to clarify that infrastructure here doesn't necessarily mean hardware. It could be a data infrastructure, it could be a software infrastructure that as fits for a need for the community. Then in the top right corner, you see a bunch of different circles there or ovals there, depending on the size of what it is. The Chameleon and Cloud Lab falls under the Future Cloud here. Then Cloud Access is the Cloud Lab, Cloud Bank program. I'm going to talk about that in a little bit. And then IRNC is the International Research and Network Connection that provides connectivity for to scientific instruments across the world. Power is the wireless platform, and mid-scale 1 and mid-scale 2 are open solicitations. Mid-scale 1 is in the range of $6 million to $20 million, and mid-scale 2 is from $20 million to $100 million range. And so if you can put together a team, you might be able to put some really cool stuff out there for the community to benefit for it. And so with that, I want to kind of point out a few things. I'm going to give some example from mid-scale that we funded last year. Last year, I mean, sorry, 2 years back. And then there's a new solicitation from last year. The announcement for the one selected will be made in the next week or two. So I cannot tell you the secrets right now. Then I will briefly talk about IRNC because of its connectivity to the mid-scale program. I will also talk about a little bit about the future cloud, but you'll be more familiar. You're already familiar with that one, but briefly I'll mention it. And then power program for the wireless I'll talk about. And then, you know, I will give one example of the CCRA for your information. And so hopefully Kate is tracking my time and let me know what it is. The fabric is the one that was funded under mid-scale research infrastructure project 2 years back. I put the link in there. It's a testbed. It's actually a new paradigm for distributed application and internet protocols. It provides, it's being built right now. It provides in-network compute and storage with a programmable testbed. It's a network spanning the entire country. They're in the process of rolling out the phase 1. They have their development nodes already up. They're in the process of rolling out the phase 1 nodes. A slight delay because of the COVID situation, as well as the shortage of chips, you know, that many of us have heard about. It will have the GPUs and FPGAs and network processors, a dedicated optical 100 gigabit link to all the way to terabit link. It also interconnects to the high performance computing, cloud and wireless testbed. And that's why it is very, very interesting and whatnot. And design and test application you can do. And of course, science cases goes from IoT sensor to cybersecurity, AI, ML, and whatnot. So this is the picture of the fabric testbed. So what you can see, the yellowish line talks about the fabric testbed, which will have the terabit per second link. And if you're wondering why we had to do, or they propose it in terms of mix up of 100 gigabit and terabit, it's had to do it the budget, although it's a $20 million project. It has a lot of components, as you can see, a lot of sites there that they're connecting it to. So it's, you know, and it's actually, it costs a lot of money in terms of equipment and all the connectivity. What you will see, a couple of things I want to point out about, you will see the chameleon connectivity, we're showing it here. It's going to have connectivity to fabric testbed. Chameleon's counterpart is the Cloud Lab, which is at Utah as a host. Utah also happens to be one of the wireless platform called Powder that is connected there. Another wireless platform is the Cosmos here at Rutgers. They will connect to New York City hub here. And you can see, and then of course, through our Cloud Bang effort, you can actually connect the public cloud providers at San Diego. So this is, although it is a network testbed with advanced in-network computing and storage, it also thinks about what else we can connect to make it a bigger and better infrastructure to do a bunch of different things that you cannot currently do it right now. So I now jump to FAB. FAB stands for Fabric Across Border. It was funded under International Research and Education Network Connection. And, you know, and it obviously takes it a step beyond what I showed up in the US map. And it also international connectivity. We will also do the 5G and wireless connectivity. It will have a smart cities testbed and science instrument, and a partner with domain scientists to optimize the global scientific workflow. That's a very, very important part of it. It develops the software building blocks and demonstrates the use towards a high-speed programmable multi-point connection. To give you a little bit of flavor of the FAB international connectivity, I showed the 3 parts where it is going to be connected. Let me start with the one on the East Coast part of it. is going to connect to all the way to CERN in Switzerland. And the Bristol is another big important hub. And we have partners, this is going to have a partnership with Giant and everything. So this is going to give you this connectivity there. On the west side from the Seattle and San Diego, we're going to connect to University of Tokyo, so we're going to get fabric connectivity to Japan. And so that's provides another very important connection for us. On the south side, you can see that from Florida, we actually go all the way to Santiago, Chile. And you are wondering about what is in Santiago, Chile, is that's where one of our big telescopes are. Sorry, not Santiago. In Chile, there's close to Santiago, there's a big telescope is there. And they're going to pump so much data for with the next set of experiments they are doing, that the international connectivity to get the data all the way to, let's say, in the Boston where the MIT is, or Caltech, or wherever it is going to be stored, is going to be very, very important. But I want to kind of bring something important to this briefly, that 2 years back in April 2019, many of you probably saw the black hole image, and that captivated audience around the world. So exciting and whatnot for, of course, people in sciences and for us. But what I want to tell you, that the data it was generated from the experiment collected over 7 days with 6 different location of satellites was in the order of 5 petabytes. Believe it or not, we did not have a network capability at that point to transfer that 5 petabytes of data. And so what they had to do it from, I think from Hawaii to Boston, they had to ship it by airplane. So you understand the importance of the network. With the next generation Event Horizon telescope, that's going to do more work in the space of black hole, which is we actually NSF funded through another mid-scale effort. And that's going to generate about 100 gigabits per second of data that we know of. So we want our networks to be ready to be able to allow to do science the way we wanted to do it in the next few years. So Fab, I'm not going to go over all of them. I kind of mentioned already about the cosmic stuff related to that. That's the Vera Rubin Observatory. I just talked about LSST, weather science, high energy physics, urban AI at the edge. I'll talk about SAGE in a second. And of course, for computer science, 5G across borders, software-defined network, chains economics, and sensor resilient protocol and whatnot. So a bunch of different activities with the international thing that's going to allow you to do. SAGE is our software-defined sensor network. It's an AI at the edge, very important thing. This is also a mid-scale project. I have provided a link there for you to be able to see what's part of that. I'm not going to go over all of the items on this slide. You can see that it will have a bunch of different sensor nodes across the country to be able to collect the data. And this is also where the network connectivity is important to share the data and experimentation and all of these things. So this is machine learning for the edge. It's going to be very, very interesting what actually that can be done. So I put the link in there. You can kind of see what you can see there. So this is where, the left side of the Chameleon, where that started in 2014. Now we're in phase 3. And I don't need to repeat that. In fact, there's going to be a session right after this talk about giving more overview about Chameleon. So we have 2 research in cloud testbed. Besides Chameleon, the other one is Cloud Lab, which is at the University of Utah is the lead. Each of these things provides different kind of capabilities, and both of them are also looking at the IoT at the edge, which is great for the phase 3 part of it, what we want to see. And if, for the Utah one, sorry, the Cloud Lab one, Utah, Wisconsin, and Clemson are the partners. And of course, for Chameleon, Chicago, North Carolina, Northeastern, and the Texas Advanced Computing Center. Cloud Bank is our new initiative. It's operational for over a year now. This is the one where public cloud can be connected to give research to make it enable research in computer science to our scientists, for those who need actually a public cloud to be able to do more elastic computing sort of a thing. So, and we have now partnership through the Cloud Bank with the AWS, Google Cloud, Microsoft Azure, and IBM Cloud, and we expect Oracle Cloud to be part of that partnership as well. So you can go to cloudbank.org to look at what they have and more information about that part of it. So let me switch gear and talk about Power. That's about the platform for advanced wireless research. And so, and for this one, we started several years back. We now have actually 4 different platforms for that. Let me go over first, what are the different goals about the Power platform? It's really for allow to do wireless innovation and development and going even beyond 5G. It has the millimeter wave, virtualization and network slicing that actually connects also to the core network part, microservice architecture, AI, obviously spectrum optimization, massive MIMO is a very important thing. And of course, virtualization, open radio access network. We also want to look at resilient and secure 5G and beyond. In fact, we had a new solicitation that was announced called RINGS that had a deadline fairly recently, is over, and talked about the 5G and where the many industrial partners are there. And of course, for the application services, what we'd like to see in the context of smart and connected communities, cyber physical systems, cybersecurity and IoT, robotics, and smart and connected health and big data. So it serves a lot of different things purpose there. So they can use the resources in a number of different ways, wherever you want to do, for example, programmable massive MIMO, or dynamic spectrum management, all of these abilities there. One of our platform actually unmanned aerial vehicles, which is the drone thing. I'll talk about that in a second. So let me kind of talk about this of the platform a little bit. The Powder, Cosmos, Airpo, and in fact, we now have this one announced. I forgot to update this thing, but I have a separate slide to be able to talk about it. First thing I want to point out, the Powder and Cosmos, FCC has given us a spectrum for research purpose. It is known as the FCC Innovation Zone, which is pretty cool in terms of being able to have experimentation done and check it out without interfering with production, commercial service provided by commercial, wireless providers like AT&T, Verizon, and T-Mobile. So the Powder platform, Utah is the lead on it. Rice University's partner. It's a 2.3 square mile of Utah campus, as well as a downtown Salt Lake City. And it includes software-defined rooftop and base station radios and access to compute stores and cloud resources. And this thing is, you can actually submit experiments now. In fact, we got a bunch of different things. We have been doing it for over a year now. You can do, if you have an NSF award, you can actually request for the Power supplement to request in the range of $50,000 to $75,000 to an experimentation, to support your student with this any of this platform, by the way. And many projects requested for Powder last year. Of course, it has end-to-end programmable networking, spectrum management, and massive MIMO. So that's the focus of the Power platform. I put the link in there. You can see what's called. The Cosmos is in the New York City. Rutgers University is the lead, and you can see that Columbia University, University of Arizona, City University of New York, there were partners in there. It's a 1 square mile space in West Harlem. And so that's the one, in a different kind of a city, urban environment to see what sort of things we want to understand. It includes large and medium-sized software-defined base station radios and fiber connection to and from radio sites and to local data centers, and interconnection with other smart community. It has a millimeter wave focus for radio communication and dynamic optical switching technology. So it's a very interesting in the context of optical as well as in the context of millimeter wave from the wireless point of view. The other thing I want to talk about, before I move forward, that what we are finding is that once you want to do an experimentation like places like Cosmos or Powder or any of this platform, because the way you do the experiment is it can collect data at every level of the signal level, anything you can do to the network level of information. Some of these experimentation we anticipate to create data in the order of terabytes actually. So that's a very interesting challenge. Also comes how to process the data to be able to identify and capture different signals and the patterns and things like that. So those who are interested in doing those sort of that analysis might also will have access to some of the experimental results data that will be available to the community to use it. That this was the one with the drone. This is our new, relatively newer one. We funded it last year. And so, and that one, at the North Carolina State University is the lead. And so it has a, drones capability. They have partnership with the North Carolina Department of Transportation. They actually found a corridor to be able to use it and test out for, drone in terms of how it impacts rural and urban environment, fixed software-defined radio nodes, it will advance wireless in this context of being able to support that. And it's going to be very, very important to be able to. So one of the things they are doing, I want to tell you, is that they're actually delivering, using drones to deliver things between hospitals, because roads are so could be congested. So they use the drone for delivery from one hospital to another hospital right now. So those kind of things we want to see what works out, what are the new things we need to be able to do, and whatnot. So this is the new one. ARA is the ARA-wireless.org, Iowa State University lead. It's the rural communities that we're trying to support it, and this just got funded about a month ago. There are many partners, including John Deere, for example. They're very interested in how we can improve, for example, to rural agriculture, or we call it digital agriculture, through these wireless technologies. And so you should look out for that in terms of what can happen in the edge. Colosseum, I want to quickly talk about. It's a wireless simulator for those who wanted to know. It has a very important thing for the simulation part of in terms of RF channel simulation. I want to quickly give an example of a CCRI project. I'm being careful about my time here, just to give you a flavor of CCRI project. So it is just one representation. It's a project led by University of Alabama, with Georgia Tech and City University of New York and Michigan Tech being involved. This is an underwater wireless network testbed, mobile underwater testbed. I won't go over all the details about it. So they have actually creating two testbeds. One is an indoor testbed. It's like a tank, all right? And the other was a lake testbed, okay? So they're going to get a reconfigurable software called Micronet software. And so you can actually submit research experimentation to do that. And obviously, because it's a underwater thing, they cannot do it on real time. They're planning to, in the first year of completing the project, we have regular meeting with them. And so once that basic part is available, you can then submit your experiment. They can run it once a month or so. They're going to, so it is not going to be real time, but it allows us to learn a lot more about what sort of things we're going to be able to understand in the context of underwater wireless networking research. And so I'm just showing a couple of pictures of what indoor testbed for the swarm networking and the lake testbed they're doing at for that part of it, what they're actually trying to create. This is really, really pretty cool thing. So, we're giving the community the opportunity to come up with new ideas and whatnot so that you can actually do things like that. So finally, I want to kind of give a, what I call an end-to-end federated research opportunity in terms of the infrastructure we have. So edge, we talk about the wireless platform like Cosmos, Power, AirPro, ERA. Of course, something like Chi at the edge also creates an edge thing. I talk about fabric in the core, that connects the network. And then, of course, something like Chameleon, Cloud Lab, and public cloud. Through Cloud Bank, we have the clouds. So you could think about an experiment that's like an end-to-end experiment. Starts at the edge. It needs to use the core for some sort of a network compute and storage. It needs to use the cloud, whether the public cloud or our research clouds, to be able to end-to-end experimentation. So for that, we are working on the federation among all of these things. Some of these things are already working. So this is a great thing and where we are. And so we're very excited about the possibility for our community to do new stuff there. So with that, I'm going to stop it here and allow for a few minutes for Q&A. And I have not looked at the chat box, Kate. So if you read me the question or
well, there's actually, first of all, thank you very much for a fabulous talk. And there is we had one question about availability of slides, and we'll be collecting them from the different presenters and making them available to the extent that the presenters agree. We're also hoping to provide a recording. So if, again, all the presenters agree or some of them agree, right, and we can always edit things. So we're hoping to provide both the video and audio to everybody. And we've got one question from an anonymous attendee. Will the data collected through these sensors be available for everyone? And there were many sensors that you talked about, but is there one policy perhaps for all of them to make the data available?
It's a very, very good question. So I presume the person who is asking the question about the sensor, maybe in the context of the SAGE platform, mid-scale platform that I talked about, Waggle nodes, and from what I understand, they are planning to make the data available, so you can actually use the data. There's another important part to it. We always talk about reproducibility and repeatability of research results. And for that also, we want data to be available from experimentation that is done, because if you develop something new or compare and you want to do from a comparison purpose, we want that to be available. So yes, that's the intent and the goal for that part of it.
Yeah. And if there are any other questions, please put them in the Q&A channel. And Deep, one quick question from me. Yep. You mentioned in the last slide in particular various different capabilities of the various different test beds. Does NSF have any plans to invest in federating those test beds or supporting experiments across many different test beds, or is that not considered a directed activity?
Well, I mean, just to kind of give you I don't want to say it's $1 million question, but but just to kind of give you a little bit of flavor, but something like what we have done with Chameleon and Cloud Lab is that's for the community to use it for free. They don't have to do anything about it, to worry about it, to do it. They just request, write a 1 paragraph information, how many GPUs, CPUs, whatever you need it, or the IoT device that you need with the new capabilities, and you can actually use it. That's a great thing. We have invested that money right now. I think we gave you $10 million. I think it's around. So that's what is there. When it is something like the public cloud, obviously there's a cost to it to use the cloud. So you have to have an award or a grant to be able to do that. Fabric, we expect to experiment it. In many cases is going to be possible with without needing a funding. But we are also, remember I talked about CC Star program, which is the October 11 deadline. Under Area 3, we also have a Fabric testbed proposal. You can request it. So if you are interested in that, you want to look into that and submit a proposal under that. And so you'll get funding and then try to use it for different things. Sure. So with the wireless one, quickly, we are doing what we call the power supplements to fund it. So all of those things. Now, regarding the federation part of it, there are some challenges. We need to understand this a little bit more better and see what sort of things, funding and things we need to do in that space.
Yeah, and we've got one more question from Anirunda Gokale, which is somewhat related to the one I answered. He says, with so many different sites providing so many different capabilities, how does one go about learning how to use these and how to make the best decision on which one will apply to our work, right? And this is very much a federation question, because all those different facilities provide resources slightly differently. They cover different areas, and as you pointed out, there is some overlap between them. This is perhaps a well-formed, more specific version of the question I wanted to ask, right? How do we use those resources in conjunction?
Right. So this is a very good question, actually. We have been thinking about it a lot in the last year or so. What we have done, which is not fully actually populated everything yet, under the CCRI program, we're creating what is called a virtual organization. So I'm going to post the link in a minute because I don't remember exactly the link. So you can go there, that anything we funded under CCRI, we're going to get information about it and connect to all of the site. And we're going to populate information related to even, although it is under CCRI, things about the Chameleon and Cloud Lab and all of them there also. So it is not fully, so bear with us, because we get that's the project to somebody to handle it, as a activity. And so they are just starting to populate that information. And then I'm going to post it in this in a minute. So,
Okay.
and hopefully, and we want to hear feedback from the community, what is useful and what is not useful, how it is there, because that's exactly we want. So that, because we want to make this more usable, more information oriented, and as well as that anything you want to say, how do I do this thing, to sort of thing to be there. So that's the charge of the virtual organization, and they created that site.
Yeah. Okay, well, thank you very much. Thank you very much again for the keynote. And I would encourage everybody to take advantage of the fact that Deep is here. If you have more questions coming up for him, please continue to post them in Q&A where he can answer them directly. But we will move in the meantime to the next part of our program, which is the overview of G@Edge.